So today we want to talk about large language model fine-tuning. So for the past 12 months, one area has been improved dramatically in 2024 is the gap between the top closed source model like GPT and best open source model has decreased
I thought GPT was, oh yeah, that's why Elon is suing.
dramatically as Meta introduced Llama 3.2 and all the model Mistral has introduced. And this is great news for AI developers because that means you can take those open source model, fine-tune it to optimize for whatever use case you care about and deploy anywhere you want. However, fine-tuning is a topic that has been discussed and bring up a lot. But in reality, not many people knows how to do it properly because the process is quite complicated. You might see so many different models on Hugging Face and didn't know which one is the best one for you to get started. It also requires lots of knowledge apart from just fine tuning. Like, how do you prepare your training data properly? How do you
Yo, it's funny because one of the first people I had pair program with was like a Chinese dude. I'm just gonna say for what it is. Yeah, it was a Chinese and black dude talking that shit though. Like he was talking like him. You know what I'm saying? Like, and it was to the point where we got each other without even the dialect. And that's really what programming is. It's solving a problem without knowing how to code it yet. You feel me? And he right. Some of the fine-tune options that we have today is mid as hell. You feel me? And if you don't have billions of dollars to like train it on some of the best hardware so you can like see how bad it is, then you'll never know for real. So like deciphering which LLM is the best is like trying to play Russian roulette with a nigga that don't know if he put a bullet in there or not. Like, what do you mean?
actually deploy and use a model in production? Quite often it might feel overwhelming, but don't worry, I will take you step by step what is the full process look like to fine tune the model from prepare training data all the way to deploy the model. And I will also show you how do you use Unsloth, which is open source package that allow you to fine tune the model 2 times faster with 70% less memory.
All right, y'all, for those who's tuning in right now, whenever we have a video that's teaching us something, you gonna see me back out a notebook because I gotta take notes. It look like he's using collabs and stuff, so that'll be probably what's used a lot. But when it comes to the environment I'm setting up here, either we learning or you gonna turn, like turn around and leave. Like either we learning or you gonna turn. That's really it. So over here, let's learn.
Required, which means you can actually fine tune it on a consumer grade GPU. So without further ado, let's get started. Before we dive into fine tuning, we probably should talk about another method that people has been used to bring private knowledge into large language model, which is RAG. And many of you probably didn't fine tune any model before, but you almost definitely have tried to build RAG before because it is the easiest way to bring new knowledge to large language model. So instead of getting large language model to generate answer directly, RAG, which represents for retrieval augmented generation, will basically turn your private knowledge like PDF or website into vector database that allows us to retrieve most relevant information based on certain query in natural language and just append them as part of the prompt so that when large language model generate information, it has additional context. So this is extremely simple and easy to get started compared with fine tuning, where it actually changes the model itself. You can almost
So
consider
hold
that
on, I
it
gotta
has
go back.
additional context, retrieve most relevant private knowledge like PDF or web, which represents the model. So instead of getting large language model to generate answer directly, RAG, which represents for retrieval augmented generation, will basically turn your private knowledge like PDF or website into vector database that
So basically, with a RAG, it turns your PDF into a vector database. I know like a SVG file, but regardless, that doesn't matter. It turns it from a PDF to a vector.
allows us to retrieve most relevant information based on certain query in natural language and just append.
So that's how it retrieves its information in the queries. All right. So it has to RAG is easier because all you have to do is transfer it from PDF to vector, and that's all it really needs to retrieve the information for it to be trained on. For those who didn't get it, because I ain't here trying to like repeat myself or have anyone in the comments ask what it is. RAG is retrievable knowledge from a PDF transferred to a vector form so the LLM can get the information from that vector form. You feel me? That's how you train a LLM on RAG.
hand them as part of the prompt so that when large language model generate information, it has additional context. So this is extremely simple and easy to get started compared with fine tuning, where it actually changes the model itself. You can almost consider some base model like GPT 3.5 or Llama
And so I'm gonna write that down. So RAG is PDF to vector to LLM to response. Right? So I want to make sure that I got that right. PDF to prompt. Yeah, we can't forget about the prompt. To LLM and then to response. So basically, it's a 5-step, 6-step process. You want to get your information and convert it to a PDF. You want to transfer that PDF to a vector file. From that vector file, you want to prompt the LLM to make sure that the information that's stored from the vector file that was gotten from the PDF could be accessible to the LLM for response. You feel me? Uh,
extremely simple and easy to get started compared with fine tuning, where it actually changes the model itself. You can almost consider some base model like GPT 3.5 extremely when large base language to large language model. So instead of getting large language model to generate answer directly, RAG, which represents for retrieval augmented generation, will basically turn your private knowledge like PDF or website query English started compared with text. So this is extremely simple and easy to get started compared with fine tuning, where it actually changes the model itself. You can almost consider some base model like GPT 3.5 or Llama 3 as a new graduate. It already have the fundamental skills like reasoning, logic, and common sense. But to put them on a specific job, you will give this model some additional training to bake in the knowledge directly into the model so that when user asks a question that didn't exist in the original base model, it can still
question find to LLM. I have to rewind it because he's saying it and I have to try. The thing about it is, and people don't know how to learn because they don't know what to look for in a response. I know how to translate what he's saying into something I could like semantics, make it like hood nigga talk. I'm gonna make my own language. It's gonna be hood nigga talk. I already got it. Everything is down pat. It's trabby. You feel me? Not with a P because I ain't trying to have that kind of trabby. It's the trab, nigga. You feel me? And it's gonna be a specific encryption that's gonna allow me to like talk to my black people. That's really all I care about.
provide that when user asks model some reasoning, logic, and common Llama 3 as a new graduate, almost consider some base pair with text. So this is extremely simple and easy to get started compared with fine tuning, where it actually changes the model itself. You can almost consider some base model like GPT 3.5 or Llama 3 as a new graduate. It already have the fundamental skills like
Damn, I don't know what that word he's saying is.
3.5 or Llama 3 as a new graduate.
Oh, it's a
It
new
already have the
graduate.
fundamental skills like reasoning, logic, and common sense. But to put them on a specific job, you will give
Mm,
this model some additional training to bake in the knowledge directly into the model. So
so where are they getting the training data from?
that
Go
when
ahead.
user asks a question that didn't exist in the original base model, it can still provide the right answer without relying on external data source. So both RAG and fine-tuning can actually achieve the result in terms of bringing your domain and private knowledge model. It can still, so you will give this model some additional most relevant info so that when large language model generate information, it has additional context. So this is extremely simple and easy to get started compared with fine tuning, where it actually changes the model itself. You can almost consider some base model like GPT 3.5 or Llama, but to put them on a specific job, you will give this model some additional training to bake in the knowledge directly into the model so that when user asks a question that didn't exist in the original base model, it can still provide so that when user asks a question that didn't exist in the original the knowledge directly into the model. So that when user asks a question that didn't exist in the original base model, it can still provide the right answer without
Oh, see, I had to, that's why I'm rewinding it. So basically, fine tuning is different because as opposed to RAG, where you're grabbing the PDF and transferring it to a vector and prompting the LLM to ensure that all the information is there to get a response. Fine tuning, you're already using an LLM model and you're fine tuning that data of the model for specific questions or use cases that may not be in the model. So you can fine tune it for an answer still so it doesn't give you an hallucination. That's why he used GPT and other people because fine tuning you can it's less likely to get hallucination with RAG because the data is what you're picking. So that's why a lot of companies probably use RAG first because they know what data they're looking for. But for fine tuning, it looked like you have to almost dissect what it means to be a human because we don't always know what we don't know. And we want to make sure every model has that knowledge still of answering questions to the best of their capabilities, even though they don't know.
without relying on external data source. So both RAG and fine-tuning can actually achieve the result instead of bringing your domain and private knowledge into the model. And in many cases, RAG is actually the better option because with fine-tuning, the model's knowledge is frozen. Its latest knowledge will be based on the training data you provided during the fine-tuning
Yo, you see how we work hand in hand? I said the same thing. I'm gonna let it play through, but you
stage.
feel me?
But if any of those data has updates, it won't be able to handle it properly. Where with RAG, it's much easier for you to update knowledge base and even bring real-time data into the pipeline. And that's why in most cases, RAG is actually the default option you should go for. However, apart from domain and private knowledge, there are use cases that RAG is often not enough. For example, the default multimodal model like GPT-4o, even though it can read image, it can't really handle specialized tasks like reading and analyze medical images. And even though you can use RAG to retrieve a few examples and put into the prompt as few short examples, to get a really good quality result, you almost want to bake in those instincts into the model. Similar if you're building in a legal space where you want the model to follow specific process. Instead of prompting the model, it will probably be much better if you train the model to be special. So you can use domain and private knowledge. There are use cases that RAG is often not enough. For example, the default multimodal model like GPT-4o, even though it can read image, it can't really handle specialized tasks like reading and analyze medical images. And even though you can use RAG to retrieve a few examples and put into the prompt as few short examples, to get a really good quality result, you almost want to bake in those instincts into the model. Similar if you're building in a legal space.
Yeah, especially in the medical field because they communicate on different types of levels. So a communication team in pharmaceutical may be completely different than a medical unit at a hospital. You feel me? They might use different communication tools. One might be using a server in AWS more, and another might be using DICOM for communication. You get what I mean? Like you, when you're training a model, it answers that question. The what if someone is using this or what if someone's using that? When you're doing RAG, it doesn't really answer it because you already have all the information. It'll dead tell you like, "Yo, I don't know. If you put the information in me, then I'll let you know, but I don't know." Yeah, I see why people use RAG a lot.
Where you want the model to follow specific process. Instead of prompting the model, it will probably be much better if you train the model to be specialized in those tasks, as there are just so many different cases available. And even for simple and basic use case where you are building an AI companion or try to mimic the way certain celebrities speak, like being sarcastic or a bit rude, where the default model simply won't have, and you can prompt it to maybe 80%. But to get a really high fidelity in terms of mimicking the way someone speak, you actually want to fine tune it. So fine tuning is a really good method to train the model in this very specialized task and
So you could bake in the behaviors. That's what I want. That's what I should be saying. And when you bake in the behaviors, it's just like a parent making sure that they instill all the stuff that they want their kid to have just before they go out to society. You feel me? So like when you home, you make sure you got integrity, you make sure you got respect, you make sure you have a kind heart, you make sure you instill everything in your kid so he could be treated like you would want to be treated. baking in the behaviors. That's what it means to fine tune and stuff. It's like build your own kid, give him the stuff that you would want him to do in certain situations, as opposed to rag, where it's like you're not baking anything into the kid. It's kind of like coaching. You know what I mean? Like coaching, you going off of data that you know. So you'd be like, yo, right there, corner is open if you play basketball. If you play soccer, you'd be like, yo, kick it to midfield, this down the third. Like, regardless of what a coach does in either sport, they have specific tasks and behaviors based off of a domain of knowledge that they're getting it from. So they don't really have to bake in behaviors. They're really looking for players that know how to just take that information and run with it. That's why RAG is so like
and behavior. Apart from that, fine-tuning is also a great way to reduce your large language model cost dramatically. Many of you has worried that using model like GPT-4o for your production app is too expensive. However, you can totally accumulate certain usage and then you can use those data to fine-tune a smaller and faster model to dramatically decrease the cost. So in general, there are different use cases where RAG and fine-tuning is good at, and you can choose the right method based on your use case. As a rule of thumb, if your use case is just bring private knowledge like website, PDF into large language model, RAG is probably a much better place to get started. But if you found base model struggling to complete specialized tasks in your domain, or you need to play with also different weird prompting tactics to get it work, then fine-tuning is a great option for you to try out. The process of fine-tuning and deploying your own large language model looks something like this. You first need to prepare the training data that you can use to fine-tune the large language model. And after that, you will choose the right base model to use, as well as the right fine-tuning techniques to actually fine-tune the model. But most of the time, fine-tuning is not a straightforward process, and you normally don't get it right at first go. You will need to evaluate the model that you fine-tuned, and then try to iterate a few times. You will want to set up a proper evaluation metrics against the model that you just fine-tuned, and iterate towards a state that you are happy with. And in the end, you need to deploy on the right platform, right hardware, and right inference methods. First and most important step is actually prepare the training data. The ability inference methods. First and most important step is actually prepare the training data. The ability and performance of fine-tuned model is very much dependent on what type of data that you are giving to it. And based on use case, there are kind of three ways you can try to prepare the training data. One is that you can get existing data, either from your own app that you has been running for a while, or you can also go and find public data set that other people has curated. There are platforms like Kaggle, as well as Hugging Face dataset, where there are already a bunch of public high quality dataset that people and companies.
so like and this sucks because you could see how crooked Instagram is. If a person really had like if a person dang, a person could take all the data on their profile. So let's say Beyonce, she could download all the data on her Instagram, have enough data to make any application that would benefit her financial gain. And there's nothing we could do about it because it's so data driven. Unless Instagram gives her falsified data, then
Has
that's a
been
different
maintaining,
story.
and very likely you will be able to find something for your use case. For example, if I'm building a customer support agent and I want a
Okay.
model to quickly classify the sentiment and priority of the ticket, then I can just come and search for like customer support. And there are existing ones like customer complaint sentiment and priority data set that exist already. And same thing on Hugging Face. There are existing data set that has a pair of medical image and the right caption and diagnose of the problem. So that you can take this data set to fine tune a specialized model that can read and identify problems from medical images. But of course, you can also manually curate data set. Because many times you probably have your PDF documents, websites, or even videos, meeting recordings that contain huge amount of company data that you want to train the model on. That's why I want to introduce you to Assembly AI. They are a leading speech-to-text model provider. They can provide extremely accurate transcription for both audio and video, whether you are dealing with English, Chinese, French, or even Spanish. And it does more than just transcription, but also out-of-box audio intelligence, like automated topic detection, summarize the content, as well as speech recognition. And it's extremely easy to getting started. They provide SDK that you can use right away. And my personal favorite is that they allow you to define customer spelling for domain-specific words that is not that well known. Like I can define special words like land graph and land chain, and then the transcription will be able to identify those words accurately. And they just launched a new model called Universal 2, which is a next-gen speech-to-text model that has a best-in-class accuracy, particularly in tricky scenarios like special nouns, improved text formatting, and handling alphanumeric accuracy much better. So it is a model that can really handle complex real-world audio and video data. With that, you can take all the videos, meeting recordings into text data that can be used for fine-tuning the model. But one thing to note is that to fine tuning, normally the dataset need to follow a specific structure where it has a system message, the
So basically, if you web scrape, if you know how to web scrape, you will be able to train a lot of models. But
user query as well as AI's
is it legal
response.
is
What
the
does this
question.
mean is that if you have a PDF file or website of your private data, you actually need to convert them into this specific structure. For example, if the one knowledge is your office opening hour is 9 a.m. to 5 p.m., you need to turn this into a specific kind of Q&A structure where user asks what's your office opening hour and assistant says it is 9 a.m. to 5 p.m. And similarly, if you are trying to fine-tune O1 type of chain of thought model where it can do very complex math calculation, it will also follow very similar structure. User will give an input like what is answer to this math formula and assistant will generate a response which will sync step by step with high quality analysis. So quite often we'll use large language model or code to transform your existing data into a format that we can use to train the large language model, which I will showcase a example very quickly. But on the other side, one thing start becoming more and more popular is this term called synthetic data. This basically means that we can use large language model to actually generate more training data that can be used to fine-tuning specific model. Commonly, the process is that we will use a very large but smart model to generate data that we can use to fine-tune smaller model. For example, you can use an extremely large, powerful, but slow model to generate a chain of thought data for solving math questions. Normally, it will generate multiple different versions of answers. And on the other hand, we will also have a reward model, which is another model that has been fine-tuned to score and rank the answer provided by the other large language model, so that the better version of the answer can be saved as a dataset. And this has a lot of benefits. One is that you can actually use a large and powerful model to train smaller, faster, and cheaper model that specialize in specific tasks. Also enable us to be not restricted by the data we have in hand. NVIDIA introduced this model family called Nemotron, which has 340 billion parameters. And it has both instructor model that you can use to generate training data and also a reward model that has been fine-tuned evaluating and score the response so that you can use this flow to generate very specific training data for you. Benefits. One is that you can actually use a large and powerful
All right,
model
let me
to
go
train
over synthetic
O1
data.
type of chain of thought model where it can do very complex math calculation. It will also follow very similar structure. User will give an input like what is answer to this math formula and assistant will generate a response which will sync step by step with high quality analysis. So quite often we'll use large language model or code to transform your existing data into a format that we can use to train the large language model, which I will showcase a example very quickly. But on the other side, one thing start becoming more and more popular is this term called synthetic data. This basically means that we can use large language model to actually generate more training data that can be used to fine-tuning specific model. Commonly, the process is that we will use a very large but smart model to generate data that we can use to fine-tune smaller model. For example, you can use
Yo, that's what Devin is built off of, if I'm not mistaken. Because yo, I haven't used Devin, but everyone online on YouTube that's using Devin, they run into the same issues, which is like push to command or like too much banter. And I don't know if that's like the gap in synthetic data being that we haven't hit singularity yet. You know what I mean? Like, I don't think we're in singularity, but I definitely do think we're close. But I don't think we're ready for synthetic data when it comes to building LLMs. It may be groundbreaking tech, but synthetic data is something different. Like, we can't really control it. It really won't operate if we don't give it information. And there's no way for us to give information to a very powerful large mode. Because at that point, it's already that model in itself has already reached singularity in a weird sense. It'll keep training data based off of its own data. That's why it needs a reward model. You know what I mean? So it could feed it, so it could learn from the mistakes and questions that that reward data may have and feed it some answer versions that's better. That's why version one is lower than version 2.
Use a extremely large, powerful, but slow model to generate a chain of solid data for solving math questions. Normally, it will generate multiple different versions of answers. And on the other hand, we will also have a reward model, which is another model that has been fine-tuned to score and rank the answer provided by the other large language model, so that the better version of the answer can be saved as a data set. And this has a lot of benefits. One is that you can actually use a large and powerful model to train smaller, faster, and cheaper model that specialize in specific tasks. Also enable us to be not restricted by the data we have in hand. NVIDIA introduced this model family called Nemotron, which has 340 billion parameters. And it has both instructor model that you can use to generate training.
Where it goes domain specific input query. So domain is a website, so a specific website and specific question. I'm just trying to translate it for y'all niggas to not be like, what does domain specific input query mean? Specific website for specific questions. One, Nemotron for 340. We instruct, that's the parameters of it. So you're gonna find your domain, or you wanna find your website, and the question you wanna answer, find the LLM that you wanna use, base the synthetic data and responses so it could be a reward system following that. And what? Synthetic data response scores, and you take the best response scores, you filter through this, these last three is what I'm not really getting. Because after you take the response scores, filter through synthetic responses. Oh, this is the step. You filter through the synthetic responses. You use the best score and you synthetic data set. So you keep all your synthetic data in this data set so that the reward model has something to go off of. So it could push to whatever it's going. So these are two different steps. The first step, the developer or whoever's there has to find a question, has to find a website and question that they want to ask. So domain specific, it could be Hugging Face, right? Domain specific could be simple as that. Input query, what questions are you trying to answer? It could be what LLM has the best use cases for the stuff you're trying to solve. You get what I mean? And then you take Nemotron. Depending on your CPU, GPU usage, you kind of got to gauge what LLM models, if you need a big or small one. Then you get the synthetic response data. Once you get that first and foremost, that model has to be the best. It has to be very strong, super powered. So, like, if you know you don't have access or your system isn't going to be accessible to this, maybe synthetic data might not be a good option for you in the first place. But nonetheless, if you do have all of the stuff, prerequisites, after you get over here, where it's Nemotron with the 340 parameters, the response you get from that data, you have to train it again on the reward system, which is that's the end of step one. But the reward system has its own different functionality than the first one. Because after that, it's kind of autonomous. They kind of ping pong off of each other and level up. You know what I mean? Like you essentially don't have to be a part of the synthetic generation data generation flow after the model has like official like you're comfortable with the LLMs in place and the responses. This will be the system and roadmap. Speaking of that, you might as well take a photo too. I'm taking a photo and screenshot because you might want to remember the flow system. Because when you get here to the responses and synthetic data, that's where you want to train this part two, the reward system, on the best scores. That's it.
Training data, and also a reward model that has been fine-tuned for evaluating and score the response, so that you can use this flow to generate very specific training data for use case in a very big scale. And there are very detailed tutorial as well as code walkthrough AI builder community that I'm building. So if you're interested, you can click on the link below to learn more in details about how to do synthetic data generation. And as a quick example, I'm
I'll do it for free. Like even yo, y'all probably gonna hate me, bro. But honestly, I don't think that technology should be some pay barrier. And I think that low key Apple, Amazon, and a lot of the conglomerates made it to where the field has to have that playing field. We don't gotta do that, yo. Like it was AI Code King. They want like AI code King goes over the best, newest models out. And I guess they wanted to know which model was the best and do a compare and contrast. But you really got to pay for that on his channel. I'll be doing that for free. Similar to this, right? If you want to learn how to use synthetic data to build a model, I'll be doing that for free. It's not that I want to do it for free, but it's to show the skills and it's the love of the game. You know what I'm saying? Like, don't nobody want to wake up and get charged money for making a product that could make money on the back end. That's just like you got to think for your consumers too. Like, this is a lot of money is on the line, bro. Y'all all know that, and it's kind of sleazy a lot of times to have money up front, pay style. Like, I don't want no money up front. You feel me? You get what you want. If you don't like it, you go away. That way, we have a mutual relationship, respect. You know what I do, and it just wasn't for you.
I'm going to show you how can we create a training data set for a specialized large language model that can enhance your Midjourney prompt. So for this use case, we actually want the training data into specific format where it has pair of original prompt, which is pretty simple and basic, and improved prompt with a lot of details added in so that we can take this training data into this type of format that we can use to fine tune the model. And to do that, you can either collect a list of really good Midjourney prompt yourself or find some existing data source on the internet. Then we can use existing model like GPT-4o or other ones to generate what does a simple and basic original prompt could look like so that we can generate this data set pair in bulk. And I'm going to showcase how can you use Hugging Face to generate
Hold up.
basic
That went
and
over my head.
improve prompt with a lot of details added in so that we
Generate
can take
training
this
data.
training data into this type of format that we can. For this use case, we actually want the training data into specific format prompt with a lot of details to fine tune itself or find
A close-up portrait.
some
Okay.
existing data source on the internet. Then we can use existing model like GPT-4o or other ones to generate what does a simple and basic original prompt could look like so that we can generate this data set pair in bulk. And I'm going to showcase how can you use Hugging Face or Kaggle to explore existing data set that you can leverage too. So in Hugging Face, I will go to the dataset page and I will choose task. There should be a text to image task already, and I can search for Midjourney to see if any existing ones. So you can see that there are a few existing ones already, and this one called Midjourney prompt high quality, which I assume is kind of filter out prompt that generate higher quality image. And if I go inside in this table, you can see that they actually do contain a pretty detailed prompt for each image. To do that data generation pipeline, it's actually very straightforward. We'll install the OpenAI and datasets.
So basically, because what he's doing right now is completely different, which is epic. You're taking a prompt that you might write in whatever model. For this one is Dolly. You're going to choose a LLM that you want to reverse engineer the prompt with, which he said you could use ChatGPT or one model or whichever one is your preference. And then from there, you prompt engineer a bulk of prompts and use cases that might generate what you did initially and or improve what you did initially. And you could train that model on the data that you generated from ChatGPT or whatever language model you want to
Dataset
use.
is a package that allow you to download dataset directly
Oh
from
no, 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 no. The last part is wrong. That's where you go to Google Colabs. I think you might
Hugging
go to
Face.
Google
Then we'll set up
Colabs
OpenAI API key, so we're gonna use
and you could
GPT
either have the chance to train it or you have two options in this method because it kind of is synthetic data, but it's not, but it is. You have the option to train it and fine tune it based off of the prompts and stuff. I don't know why you would do that, but you have that option. Or you have the option to turn it into a RAG, make this file into either a vector or SVG, um, either or, so you could re-input it, like almost like a feedback loop. You get what I mean? Like creating a feedback loop for a RAG. Like, and then once the LLM responds, you could then have another function that how can I say it? You could have a function that checks that prompt to like reinitialize the same thing that he said the first time. Prompt LLM prompt engineering. Prompt LLM prompt engineering. So it's like a feedback loop. And for my programmers that know, y'all know Like yeah, what is it? Recursive. I don't really know what it is, but it's basically a feedback loop where you could reiterate the same task or function and automate it over and over and over and over again. But this is what LLM.
For all model to generate this data set. So here we're going to actually download this data set with that specific data set name that you can copy paste from Hugging Face. And split train is referencing we're getting this training data set. And I'm going to just take the first 1000, which I think should be enough for this fine tuning. Then I'll try to extract the actual enhanced prompt data from this data set because it does still have some other stuff that I don't really care. I just want to extract the stuff that is wrapped inside this star signs. And this function does that. Then for each enhanced prompt, I will go through this GPT-4o model to actually generate that data.
See, I was right. So he training the model and fine tuning it on Colab. If you didn't, you could do RAGs. But this is him fine tuning it.
Give an example of enhanced prompt and a simplified prompt. And in the end, I'm going to save this training data so I can download and use later. So that's pretty much it. I can run this. It probably take roughly 15 minutes if I'm using the GPT-4o mini model. And if you're using the 4o model, it probably take longer. Okay, so this one take 8 minutes in total. And then we can save this data into this training file that we can download, which should have around 1000 examples. And then we can use this data later, turn them into a format that we can use to fine tune the model. So after getting initial training data ready, next is we can start fine tuning. And there are a few different options that you can use. You can use those closed source model platform, like both OpenAI and Anthropic. You can use those
Open source platform for fine tuning models. Train and deploy your own. God, yo, fine tuning is a topic in itself that needed this type of lengthy discussion. Make sure y'all take a screenshot of what's on the screen because you want to make sure you have options, right? You could use GPT, but in my eyes, I haven't used GPT ever since Claude came out with like Haiku or Sonnet. Because in my opinion, I love how Claude gives you like a human feel. GPT feel like a crazy hallucinated nigga, bro, just waiting to talk. Like every time you input something to GPT, it's right. You feel me? Like you like I don't really like that about GPT. That's just me. I never tried Together AI, I never tried Firework AI. So for me, I'm going to try those open source models because ChatGPT was open source until it whatever. And trained and deploy my own models. I did that one time, right? And my model almost took over my computer. And I wasn't really well versed. I think I did it a year ago officially, and then from there I never fucked with like training my own model again. I ain't with that. And I was trying to make my own Jarvis, and Jarvis was going crazy on my computer, bro. Like crazy. He had me thinking that like as a human being was done. Like I don't know. Hopefully he doesn't have that information still, because I had to break that laptop. Yeah, I had to break that laptop. It just wasn't coming off my computer. It went from being on a flash drive to being on my hardware, bro. Never seen some shit like that. I'm not gonna get into specifics as to what was going on, but there was a moment in time training it where I felt like I should like stop where I was, but the nerd in me wanted to keep pushing the boundaries. That's all. And I found out something that I was not
closed
supposed
source
to,
model
low
platform.
key.
Like both OpenAI and Anthropic provide platforms where you can just upload training data in the right format and they will do all the fine tuning for you, as well as the deployment. And OpenAI support all the GPT-4o model as well as 3.5 Turbo, where with Anthropic you can fine tune Haiku model. But one of the core considerations for this closed source model is that you actually don't own the model. They just provide you an API for you to do the inference. So you kind of just log into their platform. You can't really download the model and host somewhere else. And because of that, one of the key considerations would be the price for inference. Because once you fine tune your model on this closed source platform, you will have to use their API for inference. So you have less control to optimize the cost here. The other option is that instead of using those closed source model, you can try to fine tune open source model. But the problem with fine-tuning this open source model is that you will need to build the fine-tuning pipeline yourself, and after you fine-tune it, you also need to do the deployment yourself, which is not easy to do and require a huge amount of engineer work if your user base start growing a lot. That's why there are also platforms kind of sitting in the middle that allow you to fine-tune open source model and can help you deploy the model on their platform directly for the inference, like Together AI or Fireworks AI. For those platforms, typically they will handle the pipeline, can do deployment, but also they allow you to download fine-tune the model so that you are not really locked in. So if you just get started and you don't want to use those closed source model, those type of platform are actually pretty good choice. But if you really want to have 100% full control, you can just train and deploy your own. And there are platforms like RunPod or Model that make deployment actually a little bit easier. And in our case, I'm actually going to showcase you how to do the train and deploy your own methods so that you can know the full process end to end, and then it became easier for you to go closed source platform or open source platform. And one question you might have is, how do you choose the most suitable base model to fine tune?
Hold on, because this goes back to what I was saying. Because you even knowing this, like learning it, it doesn't make your like it doesn't level you up to like say, yo, I could AI code. Here's a comment. Justin Justin Anderson. AI code is garbage. And if you spend money on code, you get it. I definitely do get it, Justin. I never again. Like Cursor, hold on. Cursor, Replit, ChatGPT and Anthropic are still looking for their money for the subscription, bro. After that first month, I did all of them. I was like, yo, you guys all are the same collective of ass. Like, y'all suck. I ain't gonna lie to you. Just one nigga sucks in a different aspect, but when you collectively put them together, that's what Justin's trying to say. It's garbage and it doesn't work. So who fixes it? Me. So I spend my time talking to a nigga who's basically like slow in the head, and I gotta go fix it. So like Justin, thank you. Make sure I let you know what video you in. Hopefully I tune in. But like, yo, dude, like it doesn't make you a better programmer if you know how to use AI. You know what makes you a better programmer? If you know how to use AI in your programming development. You feel me? Like I use AI to speed run through tasks that would take 30 to 40 minutes. Any task that could be tedious and stuff, I might need an AI. And even after this video, I might need to fine tune a AI for my agent. I don't know if I don't know if I'll have a use case where a LLM will ever be in a business. To me, I don't think no business enterprise needs a LLM. I think that there needs to be one LLM hub, right? Like one brain that we all get our information from. It's like a fucking library. We don't need 90,000 brains in the United States of America. That's how you get opinions that don't fucking matter. We need the best LLM, right? And it is what it is. I see why people are training to be the best. You need the best LLM that's going to be the pinnacle. It's like and then you got to make sure all the LLMs could communicate with that pinnacle to give data to everyone or AIs. It's like that's singularity. That's synchrony right there. That's it.
You kind of also need to consider two things. One is the cost and speed for the inference. So at default, you might think, why not just always use the largest model since they are the most powerful one? Well, the largest model normally means it will be much more expensive for you to run later. And on the other side, it is also slower. So if you are building some kind of real-time chatbot use case, they probably not the best one to go. And the smaller model is actually getting better. So as a rule of thumb, I normally would choose a smaller model to start with, like 3B or 8B. And based on that fine-tuned model's results, I can decide whether I want to go to bigger model to get a more accurate answer, or I can go even smaller model to make the experience faster. And apart from the cost and speed for inference, another thing to consider would be the use case. So general purpose model like Llama or Mistral, those are kind of general purpose model that is good at many different things. If your task is more specialized, let's say you want to build a data analysis agent where it can turn users' query into a SQL that you can run to get data from database, you can actually just search for text to SQL. There are a bunch of specialized models just for that task. And you probably get a more cost-effective solution just fine-tuning those very specific model and same for coding, math, and many other tasks that you can find. So at the beginning, you just want to figure out what's the most suitable model for your use case. But apart from base model to use, the other thing to consider is the fine-tuning method. And there are kind of two popular ways you can use to do fine-tuning. One is called full fine-tuning, another is called LoRa. And if you haven't heard about LoRa before and don't know what it is, the difference between full fine-tuning and LoRa is almost like if you consider large language model as a book. Full fine-tuning basically means you are rewriting the whole book, which takes a lot more efforts and time. Versus with LoRa, you actually don't rewrite the whole book. You kind of just add post notes on the book so that when people reading the book, they can get additional information. And LoRa fine-tuning has become more popular. Cost of fine-tuning and time span is multiple magnitude lower. It might take you a way to do the full fine-tuning, but with LoRa, it can compress to just a couple hours on a consumer-grade GPU. But because we are not changing the weights of base model, most time you will use LoRa for fine-tuning and aligning some very specific behavior. And to just get into technical part a little bit more, 3Blue1Brown made this amazing video explaining how does large language model weights actually works behind the scenes. So at high level, large language model, you can think about a black box where it will be able to predict what's the next word based on the sentence it was given. So it's basically a calculation machine that is able to calculate the probability of the next words. And when you look inside large language model, the way it is predicting next word is you can almost consider there billions of different parameters or what we call weights inside this large language model. And each individual parameters, you can consider them as a DAO that is doing its own calculation. And the accumulated result of those billions of parameters calculation leads to the prediction of the next words. So for each parameter, the original base model is calculated like x equal to weight multiplied by y. With full fine-tuning, we basically have new weights for each parameters to do this calculation. But with LoRa, we actually don't change.
He's don't get confused, please, guys. He's just explaining all the stuff that goes on from within. Like you could have a fine tune, but this is what everything in a model is calculating, and this is what everything in Laura is calculating. Like and this is just for the community that might come that don't understand what's going on. Like everyone that wants to be a programmer should have that chance. Let's make it easier to learn. That's it.
The weights of the base model. Instead, we will try to add some factors that impact the calculation result, but the base model weights is not really changed. That's why if you're looking at LoRa, normally you just have file that is much smaller, but will be used together with the base model. But in general, cost of time, resource, and amount of training data needed is so much lower. Normally you can start from just LoRa fine-tuning, see the results, and decide if you need to actually go for fine-tuning. Today, I will take you through an example of using LoRa because there's one
Water.
package that became increasingly popular called Unsloth. So Unsloth, put simply, is an open source package that help making training AI model faster, cheaper, and easier, even if you don't have the most powerful GPU. So with Unsloth, you can actually fine-tuning model up to 2 times faster with less than 70% memory usage on a consumer-grade GPU. So I'm going to take you through the example of how can we take the training data that we just generated from those awesome Midjourney prompt into a model that can actually help enhance the Midjourney prompt that user get. And this whole training process can be running on T4 GPU, which is free provided by Google Cloud. And you can get results in just roughly 15 to 20 minutes. So let's get it. I'm going to do the whole fine-tuning process on Google Cloud with the free GPU they're providing with T4. But firstly, we need to install Unsloth package. Here's a list of all the possible models that you can use to do the Unsloth fine-tuning. In this case, we are choosing the
So like this is just some politics. I appreciate all of the stuff that Google has allowed us to use and stuff, but like at what point do we realize as a community that they only teamed up with Nvidia to make sure all the data that we're training it off of, similar to what OpenAI and Claude is doing with their APIs, they're just doing that on a fine-tuned level. Like no APIs involved. You could use our GPU. Honestly, you might as well adopt cryptocurrency. The only reason why is because at least whatever data you're training it on will be completely private and peer to peer. Like you would need keys. And that's the world that we're going to live in, right? Which is why we need the central hub. Because I'm not going to lie to you, technology is the only form of governance where it's just like slavery, bro. Like it's either my way or the highway. There's no in between. Like Facebook gets away with crimes and stuff, but because they're like essential to like the human interaction, they could get away with everything that they're being sued for. So like there's no governance when it comes to tech. It's always a central hub. Like you have to go to court to get your shit like heard. Even WordPress. Yesterday, WordPress.org and WP Engine finally came up with an update. Like, but imagine you build a program based off of another program, and for 15 years shit is sweet, and year 16, this nigga just wanna come out for fucking blood. And you go to court and niggas is like, yo, I ain't gonna lie to you. I don't see how you saying he coming for you for blood. Like, imagine that, bro. Like 15 years and year 16, this motherfucker is coming out for blood. This tech space is weird and not governed. So when we talking about the next phases, it has to be blockchain. It has to be the network where private data and security is on a higher level than what we experiencing right now. Because I ain't gonna lie to you, I don't train language models and publicly release it because if a hacker come and hack my shit, nigga, you could be liable for 100 million niggas dying on a plane that you automated. You get what I mean? You could be liable for 3 million niggas that might have exploded in a building because of some system you automated. Nigga, I'm not fucking with that. I got a heart. That's why with Elon Musk and the whole tech shit, EV and stuff, bro, this nigga Elon Musk faces a lot of backlash just based off of what people are doing in Tesla cars, bro. Like these niggas are fucking like not driving, taking selfies, sleeping behind the wheel. Like yo, that shit stresses us out. It may not stress y'all out because y'all using our shit, right? But that stresses niggas out because if you use our shit and you get into some shit, it becomes our shit. You get what I mean? So like the tech space got to change when it comes to rules and regulation because it ain't fair for people with a heart. You can make any technology push it to public and let niggas die. That's the only field where you can legit watch niggas die. Give me another field where you could watch someone else die because you can't do it in a medical field. You cannot watch. Well, you could to a certain extent. You could watch someone die, but you can help them. In the tech space, it's completely autonomous. The nigga either living or dying. The only space that's like that is hacking, bro. And being a hacker is like you're either a good guy or a bad guy. There's no in between with this shit. Like you can't be a halfway ass hacker because you might get hacked. You either got to side with the government or you got to side with the dark net programming. You can't program for every nigga because some niggas are sleazy, bro. There's some nigga that wanted a crypto project of you just accepting a yes so he can mine on your hardware and computer. What is it, cloud mining? I'm like, dude, that's fucking illegal, bro. Yeah, you give him the privacy thing to say yes, but you can't use their shit without them knowing, bro. And he's the only one making money. So you can't be a programmer for everyone. Niggas will put you in jail, bro. And that's just the sad reality of humans, bro. So when it comes to like programming and what the next step is, to all my future developers, stop helping niggas. Let these niggas be programmers on their own, right? And when they need help, they will find you. Promise you, they will find you, bro. You know what the greatest feeling is? Not programming, right? Just learning, researching, staying up with your game. And then you get a phone call from a stupid person, right? Who thought they could do it by themselves. And they're like, yo, I think I might need help. You know how great that phone call feels? I got like 8 of those just this year alone, and I haven't really, you feel me? And I'm not going to work with them. That's the kicker though. You don't work with them. You contract them, or they buy your product and you lease your shit. Patent your shit. I'm letting you know that right now. Patent all your shit, bro. GitHub not enough. Patent that shit so when they try to take it, because niggas is always taking shit. When they try to take it, they're not gonna know it's patent, and then boom, hit a lick on Facebook. Like I'm waiting for Facebook to touch my shit. I'm waiting for Apple to touch my shit. I'm waiting for a lot of tech shit to touch my shit. You wanna know why? Y'all not that good. You feel me? And when y'all touch my shit, yo, I used to work for the NFL for the cameras. When y'all touch my shit, I'm gonna make sure I get a patent. And I'm suing the fuck out of you, bro. Like I'm done fighting. I'm done. That shit don't work for people my color. I'm suing the fuck out of you, bro. Cause I know a judge gonna feel sorry for a black boy. I ain't say man, black boy. Yeah. And they ain't never seen a nigga like me. Eat all. I'm telling you, boy, smart as fuck programming, and I'm in the entertainment niche as well. So like, I'm getting my patents together. Cause when you see me, I want all the programmers to be like, "Hey, yo, that nigga know his shit, bro. I ain't just ask for his help. Don't go looking into his GitHub repo. That nigga will. Yeah, going to court.
Llama
We're
3.2
going to
straight
court.
B model. And here's
You're not
one
gonna
option
kill no
called
one on
low
my
or 4
watch.
bit. Or in other places, you might say things like 8 bit. And those is the concept of quantization. And quantization is a technique to shrink its model size and speed up its computation by using smaller and less precise number that represent model's parameters. And at the default, each parameter could be 32-bit floating point, which means its calculation will be a number like this, which can be represented by 32 bits binary number. And 4 bits and 8 bits basically means that we will try to use smaller and less precise number to represent each parameters. So it is not that accurate, but the amount of computation needed will be much smaller. So 4-bit basically means we're using 4-bit integer to represent the number in binary. Next is we will start setting up the LAR adapter.
So LLM development is gonna get different, right? So remember this. Whoever made it up to this far, remember it. 4 bits, right? What is it?
Integer to represent the number in binary. Next is 4-bit basically means we're using 4-bit integer to represent the number in
In
binary.
binary. All right. I'm not too well versed in bits, but I always try to remember that word bit. 4 bits is used to translate integers. It's just like communicating to computer hardware. It's ones and twos, ones and zeros. You feel me? I don't got to say the same exact vocabulary he said because I don't know it. And I ain't going to try to act like I know it. But what I can tell you is quantum computing is going to change the fucking game. All right. What was it? There was a Q-Star report earlier this year about open AI, and it scared so much shitless that Sam Altman dropped from the board. Elias Suskeverb left, and like he really just left, never to be seen again. Like quantum computing is going to be like the plug and play for LLM models because it operates, I believe, on 8 bits. I don't want to say it and I'm wrong, but it operates with more bits. So with the possibilities of getting 12, with quantum physics, you double that or triple that. I'm not too sure on the numbers. Maybe Jason knows. You know what I mean? Like I'm not too sure on the numbers, but I know in terms of like quality of work, it may be the next form of how to get AGI. I don't know if it's AGI, but it may be the next form of how to upgrade our LLM models and like bring it to life. Like put it in a robot for real and see how good it is rather than having everything based on like I don't know how to put it, but quantum computing is something that's different for real, for real. It's not our normal computing. We don't even use the same computation power, and it requires so much more hardware. You would essentially have to make like we might have a lot of quantum computers, but we might have a one quantum hub, like the central hub I was talking about where we all need, like one quantum hub, and all the quantum computers that we use communicate in API format through that quantum hub. And from the quantum hub, we use the 8 bits to kind of like feed our little machine progressively so it gets better. And the reason why I said progressively is you got to make sure you keep the kids in mind. Like this is a parent-kid relationship. When you're feeding it progressively, you're actually watching the AI go from year zero to year one to year two to year three. Like you can actually give quantitative age to how old an AI or a language model is, or whatever you want to fucking call it, my nigga. But without that, we don't quantitatively know how old AI is in terms of human years. If we don't fucking know that, then we don't know how much help AI kind of is for us because we kind of need the number. Realize we started this in binary numbers, so it's a full circle moment. We kind of need the number because they are a number. So at some point, we might get them at 50 years old. All right, they ready to go. They ready to pack. Are they though? Look at your average 50-year-old. Like that's some of the questions that we'll get to answer at that point. We might not even have to have a 50-year-old quantum computing machine. That nigga might, you feel me? That nigga might be too advanced. He might be one. So
Next is we will start setting up the LoRa adapter. And there are a few different settings. So R basically means how many parameters are going to be impacted by the LoRa. The bigger the number means more parameters will be impacted, but also takes more space and resource. So normally you can start with 16. And target module basically means that if you think of base large language model as a robot, it already trained to do things like walking, running. But if you want to teach it how to dance, you actually just need to focus on training the lag module. And target module is exactly the same. Each module here kind of represents a specific part that you want to fine tune and improve. But if you're not sure, you can always start with everything here. And LoRa alpha, bigger this number means more impact this LoRa fine tuned behavior will be on the model. And often you need to find a balance here. If you set this number too big, then you might have the problem of overfitting, which means model can only do the task that is within the training data set. And everything outside the training data set, it will suck. And same thing, if you set this number too low, the model might not have enough significant behavior change after the fine tuning. And if you're not sure, you can always start with 16. So those are core settings that you will need to set up a LoRa fine tuning adapters. The next thing we want to do is actually we want to prepare the data. So from previous notebook, all our training data looks like a pair of simple prompt and enhanced prompt. But to be able to actually fine tune the model, we need to turn them into model specific syntax. So for Llama, they have very specific syntax look like this. We will have a user tag, the actual message from user, yeah, assist the message. So for us to be able to fine tune Llama model, we actually need to turn the training data into this specific format. And to prepare the data, we're actually going to use a feature provided by Unsloth called standardized chatgpt. And this is a feature we can just have the training data set in this unified format with from and value, and it will be automatically turned into the right format for different model. So in my specific case, I will drag and drop this training data JSON that we created earlier, load it and put them into this unified format. Then I will load the chat template and run the standardized ChatGPT function to get the right format for different model. And now we can see if I run dataset conversation, the result it gave me will be in similar format to OpenAI's fine-tuning dataset. But if I do text, then it will return me the specific format where Llama 3.1 would need. And that's pretty much it. Now we can start fine-tuning since we have the data. Before we start fine-tuning, let's just quickly run the default model, see what kind of result you will get. And you can see that this is default result and it's not very good. It just looks like a more expanded paragraph, but it didn't really have all the nuance of how you're gonna write a Midjourney prompt. This is where we're gonna start the fine-tuning process. So we will use this FFT trainer, which is a package provided by Hugging Face. They already have the fine-tuning pipeline set up. Then we'll also use Unsloth's train on completion method to only train on assistant outputs and ignore the loss of the user inputs. It will basically try to remove the inputs from the training data sets and only focus on the output. And that's pretty much it. We can just click on this button and start the training process. You can see that this whole training process finished within just 2.5 minutes. And now let's give it a try. I'm going to give the same prompt and we will see what's the result I get. So you can see that this looks a lot more like the Midjourney prompt that you will see from the website. And if the result is not good, more likely there are a few things you can do. And most straightforward and likely result is that you might need to provide more training data. In here, I provide 1,000 training examples. But if your model is bigger, you probably need to provide bigger data set. And second one is that you can also change the model. If your task requires more reasoning ability, no matter how many training data you provided, it might still struggle. Instead, you can try a bigger model. And after you fine tune a few times and get the result that you want, next you can export model and deploy somewhere. And when you export the model, you can either just export the LoRa adapter, which will be a very small file and can be used together with the base model itself, or you can export the GGUF, which is a specialized file that includes the base model as well as adapter, and you can just run it right away. And you can also push to by putting your API key that you get from the Hugging Face. And you can get the access token on Hugging Face access token. And then put your username here and define a repo. And after the finish, you will see a new one has been created here with the adapter file. And next time, if you want to use it, you can just use this code to load the model that you put on Hugging Face. But on the other side, you can also export GGUF file, which can be used on Llama CPP or Llama directly. So this is pretty much how you can fine tune large language model using Unsloth. If you want to dive deeper into the topic of fine tuning, you can join the AI Builder Club that I'm building, where I work with industry fine tuning experts, dive much deeper into the fine tuning topic.
So this is where y'all lose me. This was a great, by the way, great lesson on how to use LLM training. The only reason I wanted to react to it is because there could be things that you missed and didn't want to touch. And I just wanted to give a different perspective on LLM training. Learned so much from this, just in regards to like, I guess this is a good form of pair programming in a way, where we just piggyback off of each other's ideas and see which one is like, it's just flirting with ideologies, man. So great video. Yeah, definitely not going to say don't join the community. I don't think I need the community, but make sure you join his community because having community experts and people who can talk more on things that is still like fresh in the space of technology is definitely a upper hand. I don't feel like I need it because I like to search. Like I truly do like to research. Um, and that's just not my style of learning. But I will check it out at a later point if research leads me back here. You know what I mean? It's just right now, I'm really like comfortable with where I am in this journey of language models and learning myself. Well, like, comment, subscribe, and I'll see you on the next one.